Hello, hello. Good morning, good afternoon, good evening, depending on where you are or at the moment you are watching this streaming. So, hi, nice to meet you. If you don't know me yet, I'm Karina Varela and I work for Red Hat. And I'm super glad to have one of the engineers that work for the key projects here at our live streaming. So, if you don't know what, let me put my face just here so we can chat a little bit before we start. If you were asking yourself what key is all about, right? Because this is the key live. So key means knowledge is everything, and key is a community umbrella for all open source engineering works that business automation builds on. Projects like JBPM, Drools, Optaplanner, and our most recent project, Kogito. And to bring a little more of what we can achieve with business automation, especially on the cloud space, let me bring on board Tihomir Srdlovic. Hi, Tiho, how are you doing?
Hey guys. Yeah, I'm doing fine. How are you?
I'm okay. It's great to have you on board. Can you please tell us a little bit more about who you are and what you do?
Sure. My name is Tihomir Shurdilovic. I'm a developer at Red Hat. I've been around for 12 years now, mostly working on business automation. So I've been one of the developers of JVPM, and currently I am working on Kogito.
Ooh, that is awesome. And I've heard that some people also usually get the name of the project wrong. So we are talking about Cogito. Some people get it wrong and say like, it's not mojito, it's not cojito, cogito, cogito, right, Tio?
Yeah, I think so. Yeah.
Or cogito, but do not go for any other type of pronunciation. So can you just give us a little bit of an introduction of what you're going to talk about today?
Sure. Just to start us off, the agenda for today's talk is I'm going to give a overall introduction about the current space, kind of like looking at IT and business automation. Then I'm going to talk about Kogito, or our new business automation engine, kind of why we looked at it and why we changed what we had in order to get us where we wanted to be. We're going to look at the current state of orchestration, so serverless and workflow orchestration in general. We will then introduce the serverless workflow and the specification that we're using within our business automation suite. And we will take a look at examples and use cases on how the specification can be used within what we're doing. At the end, I plan to also show a demo of pretty much everything.
So we are going to have demos, and people who know me knows how much I love live demos. So let's see it. So Tiho, the word is yours. Go for it. It's your show time. Should I interrupt you as people have questions, or should we save the questions for the end?
It's up to you. I mean, whatever is you seem better, it's fine.
Okay, so people, feel free to drop your questions, and I'll interrupt Tiho as we go. Okay. Good presentation, Tiho. I'll be here.
All right, thanks. All right, so let's go on to introduction. When we look at current IT and everything that's going on within IT, we see a lot of requirements or these words that our applications need to be. They need to be currently serverless. That they have to be microservice, loosely coupled, event-driven. They have to be isolated. They have to run in a cloud or some sort of container platform. Our applications have to be scalable. So all of this we have to somehow accomplish. But the underlying thing behind all of this is really an architectural approach to move us from our monolith applications where we deployed all our apps bundled together, deploy them as one single unit, and which really didn't pan out very well because of a lot of different reasons, to a more of a scalable and event-driven architectures where our services are independently deployed. They're very business or focused on very small parts of our business, and they can run on different platforms, some different containers, and can communicate or be executed by events. The way I kind of look at this is, if you guys ever seen like a three-legged race where your leg is tied together with another person. And in this picture on the top, you'll see if one of these kids fall, all of them are probably going to fall. And this is kind of like what our monolithic architectures in the past, where to something more of a free, where you see these kids running, where each part of our application can independently scale, be isolated, and scale on its own without affecting the rest of the architecture that we have. Now, once we have all of our small pieces or our microservices deployed and built, we still have to see the big picture. It doesn't really solve a business problem. And we really want to focus and say that really, in the end, knowledge or domain really is everything. Our microservices independently on their own make little to no sense on their own, but we have to combine them, and we have to put them in some sort of ways that they're important to our business and to our customers. And the same microservices that we might have deployed might have a completely different value to different parts of our organizations. For example, sales might see this thing differently, or the use of our microservices, than HR and things like that. So we need this domain-specific view of our business or our microservices in order to really be relevant in today's world. Now, this is where service orchestration comes in. We have to somehow orchestrate or put together our microservices or the individual parts of our applications in a way that it makes sense to our business and at the end to our customers. And a lot of these cloud providers have seen this, and not only they allow us now to build and deploy our microservices, or these functions as we're called, but they allow us to orchestrate them in a way that it makes sense for our business. At the beginning, at the early stages, there was pretty much just sequential execution where we execute one service at a time. This moved on to things like message queues or topics. That in itself ended up, it worked great and it works, but it's hard to see the big picture of the business or the whole domain of what we're trying to build. And finally, we started seeing this movement towards workflows. So why do we want to use workflows? Well, workflows have been around for years, and they're really good at this thing called separation of concerns. We're able to really separate our business logic, which our microservices should really concentrate on, and the actual orchestration logic, which includes control flow logic and things like that. In addition to that, workflows allow us to really be able to maintain and manage state between our microservices or our functions, as we see. Another thing workflows bring to the game is really they're also domain-driven, which means workflows on their own can have domain-driven aspect to different parts of our businesses. For example, marketing, sales, HR, finance, or you name it, or even to our customers. So we kind of went ahead and said, okay, how do we fit in within this new architectures? How do we fit in within the new IT world that's happening out there? And we kind of look at, okay, what about this traditional BPM? And this is kind of what we have been doing and what have been involved with, like, for example, JPM and stuff like that. And we've seen that we don't really fit in there. Why? Because BPM or traditional BPM typically are associated with big product suites. They're difficult to maintain. They made traditional BPM kind of made the assumption or the promise of a single button that kind of manages your entire IT or your entire business. But that was really kind of only a promise at the end. Traditional BPM are difficult to scale in this new IT environment. And they're typically very tightly coupled, or as we've seen before, monolithic type of applications. So we kind of made the decision, okay, we have to modernize BPM. And what does that really mean? We have to allow our BPM applications to be decoupled. We have to scale individually. We might because all of the environments are currently everything is polyglot. All the containers, you can write really your microservices in any language. So we have to kind of follow that as well. And we have to be cloud native because we have to deploy our BPM solutions to the cloud. But at the same time, one thing that I want to mention that is important is no matter what we do on the architectural level, we still have to provide value to the business. Business automation, no matter what your architecture is at the end, still provides huge value to our businesses, no matter what business you are. Because being able to describe your business requirements, what you're actually about, your expert knowledge within your companies, and be able to describe it and execute it in a domain-specific way and language spans beyond architecture. So what did we actually do? We took our battle-tested or mature type of technologies, of course, Jules and JPM, Jules being our rule engine and JPM being our business process runtime, and converted them in this thing called Kogito. And what is Kogito? Kogito is our new event-driven, cloud-native business automation runtime. It is still based on standards. It is still open source. So that hasn't changed at all. Now, what does cloud-native business automation really mean? What Kogito really is you define your code in your business assets, for example, rules, you see DRL, your business processes, your decisions, and any custom code that you might have. There might be database access or transaction management or whatever you currently have. You run it through Kogito. What Kogito will do, it will run code generation and optimization against your business asset to generate domain-specific microservices. These microservices that we generate, they can run both on Quarkus and on Spring Boot. So you have that option. It's independent and will be generated for you to actually run on those two platforms. Now, what does the big picture look like? Once I've generated my domain-specific microservices, Kogito offers a CLI. The CLI allows you to easily go from your microservice or even a simple, for example, rule or a business process. You don't really have to, it will generate the microservice for you. So you can go from your business assets to a microservice, which then can be deployed on a container or a cloud platform. We have on the containers and cloud platforms a Kogito operator because we're trying to run in the cloud. Currently, I believe it's targeting OpenShift, but we're working on one for Kubernetes as well. And what does this operator do? It does provisioning of your application. So it will look at your microservice. It will see, okay, what do I need? Do I need persistence? Do I need messaging service? Do I need data indexing? Do I need some sort of security? It will kind of look at your domain and your definition of your business, of your assets, and figure out under the container what services are needed to run your microservice on the platform, and it will hook everything up for you. So when your services actually you want to run them, everything that they need is already present. Kogito services, we have a runtime service, of course, but there is also a lot of add-ons. If we, for example, had a business process that needs to be long running or needs persistence, or a business process that we want to scale down to 0, but then when another request comes, we want to scale it back up and continue its execution, we do provide like persistence services based on key value pairs. So all the services that we use are actually going to use technologies that are scalable and are also available on the container on the cloud that you deploy your services on. So what about orchestration? Now, the way we kind of looked at it is our first idea was just use the same thing we define our business processes with. That unfortunately kind of failed a little bit. Why? When we look at orchestration of microservices, and especially on container platforms, it has a much smaller scale than actually writing our business processes. The BPMN2 specification is huge, and there is tons of same ways or similar ways to define the same thing. Typically, the way we define or develop our orchestration or model them has to be embedded. And currently, everything that basically you write configurations in JSON or YAML. And that's pretty predominant right now in all of the container deployments. Excuse me. Oftentimes for orchestration or microservice orchestration, we do not really need tooling. BPMN, as we know, is highly dependent on visualization. And also one of the things that we realize is that in order to clearly describe our serverless orchestration, we need a clear serverless construct and patterns to do so. And we're gonna see what it is. So we went out and started looking at the current space. What is out there? What kind of technologies are out there that offer serverless orchestration, and what do they do? And we found a bunch of stuff. And this is just a slide that shows. Now, these you probably heard of almost all of them probably, and they're all great technologies. They're not specifically just for serverless orchestration, but they offer a way to orchestrate workflows within the cloud or container environment. And this list is growing almost every day. Now, what did we realize when we seen all this? The problem is, even though all these technologies are great and they're useful, some define pipelines, so orchestration for pipelines, some define orchestrations for workflows, some do both. The problem that we found is no matter what we looked at, there was no standard. And going back in the slides that we talked about, we try really, no matter what we do in Kogito, to really rely on standards, because I think that's something that it's important in moving forward in the future. So because of this, what we have realized is that in the current space, there is a lot of different ways to run into a vendor lock. One is on the workflow model level, and the other one is on the notation as well. So no matter which solution you currently pick as far as serverless orchestration or cloud or container-based workflow definitions or models, you're going to run into a vendor lock. Now, on the runtime side, there's really nothing you can do. That's it. But at least what we were trying to look at is a way to define a workflow model which can easily be vendor neutral and portable. So no matter how you define your business or serverless orchestration inside of Kogito, you can take that and hopefully move it to your next or your future cloud providers as well. So we were kind of bummed out about this, and then my daughter is actually going to laugh at me for using a Pokemon reference, but then a wild specification appears, which is a serverless workflow specification that we'll talk about.
Not just a daughter. I have to admit, I love it. Please go on.
So anyways, one of the things that we found was Cloud Native Computing Foundation has a serverless working group. And this is the group of really great people who have been involved with them for over a year now that have created a cloud event specification, which is also a specification to really unify the format of events that you send and your serverless applications communicate with. So this working group has created a subgroup for serverless workflow. And this started about late in the 18 and has been really started off by big companies. However, it ran into some roadblocks. So when we kind of got involved in it about a year and a little bit ago, it was kind of in a stagnant state and wasn't progressing. So we kind of got involved, we being Red Hat, and started contributing heavily to the specification. Currently, the specification is almost, we're going to release a 0.2 version. It is in active development, and we're seriously looking for contributions and community involvement. So if you're interested, I think here is the link to get you started on the bottom, and I think I have a slide on how to contribute as well. So we looked at this and we said, okay, this is CNCF. They host Kubernetes, the host cloud events. It's a really company that, or organization that really values about open source, specification-based stuff. And we said, okay, let's see if we can actually use this. And the outcome so far has been very positive. So what is the serverless workflow specification at its core? The serverless workflow specification defines the JSON schema. This is the schema of the model of how you can describe your serverless orchestration. Out of this JSON schema, we can generate a lot of different things. For example, APIs, TCK, and stuff like that. We are relying on implementations, and this is what we'll see. The Kogito is one of the reference implementations of the specification. But implementations have to provide, of course, the runtime, and they have to use the SPIs and APIs generated from the schema, and they have to conform to a TCK. So what is the goal of the serverless workflow specification? Is to use this markup defined by our JSON schema, which can be both JSON or YAML in this case, so they're equal, and be able to execute that markup on different runtimes. So it's vendor neutral, platform independent, and those runtimes can then do serverless orchestration on many different cloud platforms. So the idea is to unify everything that we have seen, all those different applications and offerings that have some sort of workflow or orchestration definition, to have a single specification-based language that can be portable and vendor neutral. So that's kind of what it is at its core. Now let's talk a little bit about the serverless workflow specification. The model is actually very simple. This is example of with using JSON, but you can just translate this into YAML as well. It's equally equivalent. Each workflow has things like ID, name, you can define a version, things like that. But the three core parts of the serverless workflow model are functions. Functions define reusable function definitions. So we'll take a look at that here in a minute. The second thing, because all of our microservices or the services that we're trying to orchestrate on cloud platforms are event-based or event-driven, we can define a list of reusable event definitions. Now, at the end of it, we have this control logic or flow logic states, which define our control flow logic, and they can then use or reference the functions if you wanted to execute, for example, something, or they can reference events, either to consume the events for things like starting workflow instances or continuing workflow instances in some cases, or they can actually produce events as well. They can be then later on consumed either by whoever is actually listening to them. It could be other orchestration workflows as well. So it's a very dynamic type of structure that we're dealing with here. Now, let's take a look quickly at function definitions. One of the things that we're trying to do is really define and be able to execute any types of microservices which are exposed either via REST or some other ways that is possible. So we can define, like for example, this is our definition, for example, to run a Lambda on AWS, or we can actually define a custom type of GET, which then we can use a REST API to contact this service or invoke this function and things like that. So you can really kind of define your own and really be able to execute anything you might want. As far as events, one of the core, because of course the serverless workload specification came from the cloud events team, for event definitions, we do enforce cloud event format. So as far as events, we have things like type, source, and we also do can define event correlation. So multiple events can correlate to the same workflow instance, for example. And for that, we can use a correlation token parameter, which just references one of the parameters in the cloud event that can be used to reference, for example, multiple events to the same type of orchestration instance. One second. All right, as far as states goes, so we said those are the building blocks or the control flow logic blocks. Each state has a name and it has a type, and we'll see the types of states here in a minute that the serverless workflow specification define. There is no specific start state. Any state can define that it can be a start with the start definition. So in this case, we have a my state that defines, says, hey, I'm a starting state of the workflow, and I'm a default start, so it's not an event-based start, for example. Then each state type has type-specific parameters depending on what kind of control logic block it is. And each state can also define that it can end. It's an ending state of the workflow execution. So in this case, we have a end definition, which kind is event, which means, okay, the state says whenever I am done, the workflow execution for this particular instance should end. But before it ends, we need to produce an event. And for that, we reference one of the event definitions that we have seen, and we can pass some data, which then become the payload of the event. If I do not end the workflow execution, or this state doesn't, we can transition to the next state. Now, transitions themselves, if you look at the specification, can also produce events. So it's a very event-driven type of definition that you can do.
Hey, Tiho.
Yeah.
Will you show later, maybe on your demo or in a slide, how the REST parameters are passed into the services, for example, in a REST URL?
Yeah, we'll take a look at a whole workflow definition for the demo.
Good, thank you.
That hopefully will explain. So just kind of to finish off the description of the specification, currently the specification defines 9 types for states. Probably the most notable one is the event state, which is a state that can consume events. It can say, okay, these 3 events or 4 events or union events triggers workflow execution, stuff like that. Operation state basically is just operations that need to be ran in order or in parallel, or I mean asynchronously or synchronously. So this basically function invocation. A switch state is kind of basic gateways. The specification supports currently both database and event-based gateways. Parallel state is actually, you can define parallel execution of branches, things like that. So you can look at the specification and see what each state does and how you can use it within your orchestration. One of the important things that, for example, our business automation brings is not just domain specific, but we also have things like human interaction. Human interaction or human decisions are very important, not only in business processes, but also orchestrations. And to support that, the specification also defines a callback state, which says, okay, I have a manual decision step during my workload orchestration. I have to wait for a result of that in order to continue. So that is also supported on the model side, and also, as you will see in the demo as well, that's also a big part of Kogito as well. Now, please, if you're interested in this, please get involved. Here is all the information that we have. This is we have monthly Zoom calls. Here's the GitHub information, the license, the community information. We even have a little blog that we have started. Recently, we got a new GitHub repository from CNCF, so we're kind of starting to migrate to that. So there will be hopefully in the near future a website and a wiki and all that, which currently is not there. But if you're interested, please get involved, get in the calls, open up issues on GitHub and stuff like that. I would really appreciate it. Now, let's put it all together now. We talked about Kogito. We talked about serverless workflow. Let's kind of see the big picture of what we're trying to do here. As far as Kogito goes, in the end, serverless workflow markup becomes just another asset to the engine. Just like we said, DRL for rules, BPMN2 for business processes, serverless workflow becomes one of the assets which can be consumed with the Kogito runtime goes through the same exact code generation and optimization techniques to be able to now not only create domain-specific microservices, but also domain-specific orchestration services. And that's kind of like where we're at right now. We currently are working on the runtime implementation and the API and the SPI, which will contribute back to the specification. These are currently Java-based API and SPIs, but we're looking for community to get involved and hopefully create those in different languages for us or help with that. And this runtime is able, API SPIs, to parse the serverless workflow markup and then translate that into a runtime execution. So those actually serverless workflow orchestration markup can be actually executed in the cloud or a container platform. Now, what is the big picture? So what is kind of like a use case? We have to understand that with Kogito, and especially service orchestration or workflow orchestration, we're not trying to replace anything. We know there is already existing pipeline solutions, integration definition, for example, Apache Camel comes to mind here. Already existing workflow services already running on your containers. You might be using those already. We're not trying to replace that. We have to find a way to fit into this. And that is something that we have to do. Now, the way we fit into this, we have to say, okay, we have all these different solutions or applications that are running in our cloud platforms. The way we see ourselves do is we sit kind of on top of that. Not saying that we're better or anything, but as a business automation platform, we can consume events or things that happen during execution inside of our containers, inside of our cloud, and we can run business-driven orchestration against it. So, for example, we might have different things that produce events. We can see those events and make business or domain-specific decisions upon them. So that is really kind of where we fit in. And not only that, but Kogito has very good support for human decisions. And that is something that, for example, currently, as we see, is lacking overall in all those other solutions. So if you're looking for domain-specific or domain-based orchestration and be able to make events or decisions or act upon events that they're domain-specific, this is kind of like, I think, where we fit in and fit in very nicely at this point. All right, so we're already at the demo part. So this is going a lot shorter than I expected, which is good, I think, for everybody. Now let's talk about, I want to show you guys a demo. Now, this is fairly small demo. It's just basically approving an order. But the overall architecture of the demo is basically showing a lot of different parts of Kogito and also the overall orchestration part that we're going to do. So the idea is basically to we have multiple clients that might be, REST-based clients, so things like people using an application on the web, for example. But we also have different things like, for example, we want to drop an order or into a database table. In this case, we just use a file drop into a directory. So we're basically saying there could be existing services that interact with the user applications already. Now, those services, the existing ones, can produce events. For example, in this case, we're going to use Kafka as our messaging platform, but you can really use whatever you have available on your container. Kogito is going to use these events to actually start serverless workflow or workflow orchestration instances. And as you will see in the demo, we are going to be able to orchestrate different services. In our case, we will orchestrate rule services or human task service in order to see if this new order can be approved or not. This application currently on top, you'll see the GitHub repository. One thing I can tell you right now, I don't have a README file right now, description. I haven't been able to do that, but I will add one as soon as possible to give detailed instructions on how to run it. Now, our application, as we said, Kogito applications can run, microservices can run both on Quarkus and Spring Boot. In this case, we're actually going to run on Quarkus. All right, so let's see if I can go back and we can take a look at the demo. All right. So let's close this up. So what I have here is basically a Maven project that is a Quarkus basically application with added our Kogito plugin for Quarkus. And the only thing, all this Java code right here is basically some small integrations with Kafka, defining some camel routes. For example, this is a route that looks at my local directory and then creates a cloud event to a specific topic that it can be later on consumed by Kogito. But really, there is no code. All we have, as far as we're concerned, is our workflow definition. So let's take a look at that. Now, let's see if I can make this a little... Yes?
Yeah, please. That was exactly what I was going to ask. Thank you.
You got it. Yeah, I can't see it either. I'm blind. All right. So what we have here, and I'm just going to simply go through this JSON. If you, again, you can do the same thing in YAML. It's also supported not only by the specification, but also our Kogito runtime at the moment. So what we have here is an orders workflow. And the orders workflow defines a number of events. For example, we have a new order event. Right now, we define it as type Kafka. The type property has nothing to do with actually runtime or execution. It just gives a little more context to the type of the event that it is. Then we have an approval decision event. And these are really the two ones that we care about. So we care about events that represent a new order arriving to our system. And then we actually have an event, which is the decision that at the end we actually publish out as far as the approval decision of our orchestration. Now we define our functions as far as these are the services that we want to interact with during the orchestration workflow. One of the service is we want to access a rule service. And the first thing that we're going to do when we get an order is let's see if we can auto-approve it. And the business rules are perfect for this scenario. They can evaluate the payload of the event that starts the workflow instance. Sorry. And tell us right away, okay, can we auto-approve or not? So for that, we have one function definition. For another one, well, we might need human interaction here. And we might need actually a manager. If a rule say, okay, we don't know if this order can be approved. We need a manager decision. We have a function or a service, a human decision service, which we want to invoke during the orchestration process. And those are really the two services that we interact with for this type of orchestration. As far as states goes, now our workflow has to be invoked when an event happens, a new order event, which is then either, like we said, either the REST application APIs or the integration components within our cloud infrastructure or container infrastructure has picked up and created an event for that. Now, we use the event type state here. An event type defines event reference. So we say, okay, a new order event, when it happens, we're going to start the workflow instance, and we're right away going to execute our rule service or call our rule service. In this case, we see the action being a function reference back to top to our rule-based service. When we're done with that, we need to check our transition defines, we need to check if we need manager approval. Now, this check if need manager approval state is a switch state. You can think of it basically as a gateway. And we act on data conditions. So in this case, we're not waiting on some events to happen. For example, we're looking at the data that actually came from as a result of the function call from our rule service. In this case, we have two choices really for our gateway. First one, it is approved. Our decision rule said, fine, we can auto approver, or not, we need manager approval. If we are auto approved, we can just, and we can say we can end the workflow, and we can send an event, which is our approval decision event, that contains our result or the decision of the approval. And that's it. But if we actually need manager approval, we come to an operation state which says, okay, I need to call the order manager approval service. And then when that is done, I'm going to actually send our decision event. So that's kind of basically a simple, and you can see with even 100 lines of JSON code, you can define fairly simple but sophisticated type of orchestration. Now, if you did this in YAML, it would probably be half as many lines in this case. So let's take a look at how this actually runs. So we're going to start.
Can you please increase the font size of your terminal, please? Too. Thank you.
What I'm doing now is I'm starting this demo. I'm going to run it, like we said, on Quarkus, and I started it in dev mode. And when it starts, we'll take a look. All right, so I think now we're good. Why is Chrome not giving me a new window? This is weird. Oh, maybe it's. So how do I do this? I thought I wouldn't have to do this, but I might have to show. Woo! All right. File, new window. All right, here we go. Sorry about that. All right, so this application is started, and we have a simple UI for it. And I will show you that orders demo. All right, so this is my awesome UI skills. Hopefully everybody can see this. But basically what we're trying to showcase here is some powers that the Kogito runtime has. On top part, we have two tables. Now, the Kogito runtime is event-driven itself. So every time we start workflow instances, business process instances, decision services, human task or human decision services, the runtime can produce events. And of course, they are specification-based format of cloud events. So the top two tables show us, okay, these are all the events that are being produced during execution of our orchestration. You will see that in a second, how this table will populate with stuff. On the bottom, we say, okay, we can create new orders. This is just some simple form, for example, the users can have, or their applications on their mobile phones, whatever. In case we need a manager approval for this order, we have a little table here that will show if our order needs manager approval. So we can right here on one page make a decision on it, and the final decisions, which we said are shown in here. So let's first go off and show you that the first part, which we said we can drop a file into a directory, which will then be picked up by, for example, Camel or some sort of integration solution, and then start our workflow instances. So in this case, I have a test order here. Let's make it real big. So this is basically order JSON, which says, okay, I'm going to buy this, and I'm going to buy a laptop, and my cost is $200. So I'm just going to, one second. I'm going to copy this order to a directory that my integration solution is. And let's see that this is actually going to do something. Oh, well, is this even working? Let's try again. Well, let's try it this way. Oh, we go demo gods. All right, let's try this. All right, so this worked. I'm sorry, I don't know why Camel. Maybe I have the formatting right, but this should work as well. if I drop this test order to the orders, it should pick it up as well. But basically, anyways, when we created the order through the UI for $200, we've seen that we have started here. The Kogito runtime has created a runtime event which says, okay, we have a workflow instance. This is the instance ID, and it has completed. Why? Because the rules have said, okay, the business rules have said this cost we can auto approve. And we can see in the final order decisions that this particular orchestration or the decision of the orchestration was to approve the order. Now let's take a look. Let's use it. For this, let's say, and he is buying, let's say, an Xbox which costs $2,000. In this case, our rules say, okay, we cannot, a rule service during orchestration said, look, we cannot auto-approve this particular order. We need manager approval. And if you can see the Kogito runtime says, okay, we have another instance of the workflow, but it's not completed. It's still active because we haven't completed the decision yet on the new order arrival. Also, we will see that Kogito runtime also creates human decision events. In this case, we can see that for the orders workflow, which is the same instance as this is the workflow ID. And here is our human decision instance ID. We see that it's in the ready state. And so, which means we're waiting on a human interaction during our orchestration workflow. Now here we see that the table got populated. So this is what a manager or somebody in an organization would actually see. This is just application.
I guess we are having technical issues over here. Let me talk to Tiho. Just a second. Give us a minute. Thank you. Let me ask him to join again the streaming. Let's see. I hope you are enjoying the live, and if you have any questions, feel free to drop them in the chat. I'll bring it to him as soon as possible. Yeah, I guess we are having problems, and he dropped. Let's give him a couple of minutes to see if he will join, okay? In the meantime, I will ask you the trivial. Please subscribe to our channel and give us a like. We appreciate it. Let me see where Tiho is. Let's give Tiho a couple of minutes and we will be back soon, okay? Let me see here. He will be back. Yeah, looks like he had an internet problem, and we are really sorry about it. He's joining the streaming again, so he can finish the nice demo he was presenting to us. Yeah, so I see a couple of questions here on the chat asking about UI to present where the process is right now. So on Kogito, so what Tiho is showing is another way to use assets and interact with business processes and to do orchestration or domain-driven process. So what happened is that the serverless workflow that he's showing here in the JSON specification is another way to describe your processes. So we have that way to describe. We have the BPMN, we have case management too. So what you can do is describe that, run it in your engine, which might be, for example, Kogito, and then and then once you have that, you can use the management console to see what is going on. So you can interact with using the management console, which I'll share some details with you in the chat in a while. Or you can use GraphQL to query all your data. So basically, you will have access to all of it. Yes. We still have 8 minutes left. I hope that he can join us back. It happens. It's okay. Stay on board, guys and girls. We'll be back. Just a second. Oh, so yeah, you were asking also about UI to design BPMN. We have that. If you access on your browser right now, like bpmn.new, bpmn.new, for example, that is provided by Kogito tooling. You can also access, for example, bmn.new, that is for designing business rules. So you can use this tooling. You can also install it on your local machine or use a plugin on your VS Code. So we have for tooling on Kogito, which you can use for designing BPMN standard. Yeah, I guess Tiho is having some issues, but I would like to thank you all for being here, and we will make sure that we will record his demo and make it available on this same YouTube channel. So I would like to thank you all for being here. And oh, look, Tiho, you were here. Tiho, what happened with you, my friend?
My internet went down in the
Did you
house.
hurt? Because you fall, right? We still have like 5 minutes. We were talking about tooling of Cogito because people were interested on the BPMN side of it. So I was explaining them that this is a different type of asset we can use along with BPMN specification, for example, right? So do you want to finish your demo and explain this difference on our last 5 minutes?
Well, it seems that I've been talking without internet. I'm really sorry about this, guys. I don't know what happened. But I really don't know. I'm not aware of what part of the demo I kind of dropped off. So was it at the start or kind of in the middle? Or...
I think you can follow from where you are. That's okay.
But anyways, what this demo is supposed to show is a lot of different parts of Kogito as far as runtime events and how the runtime works. You've probably seen here we deal with orders, and when a new order arrives, either we're dropping an order JSON in this case for this demo into a file, into a directory, or create or this online order through a form here. The Kogito engine is going to react to it, to the events generated by the services already working within, your cloud environment, your container platform. In this case, we have either some sort of REST service, gateway, or for example, a Camel integration endpoint. What I was showing earlier is, for example, let's say we create an order in case let's say, we want to buy a laptop, and we get this create order is actually going to call the REST API. REST API is going to see it and generate a cloud event onto our Kafka messaging service, which then will start a workflow instance. So when I create this, we see a new order being created. The Kogito runtime is going to create a cloud event, which tells us, okay, this is the ID of the instance of our workflow or orchestration that happened, and it has completed. Why has it completed? Well, our rules service that we call during the orchestration has said, okay, the cost and the shipment type, we can auto-complete this order right away. And you see here that our order here with this ID has been auto-approved. Now, let's say that somebody orders, let's say, an Xbox for $2,000. In this case, as our workflow defines, we cannot auto-approve this. Our rule service is going to say, nope, we can't really auto-approve it. And our workflow then orchestration is going to say, okay, we need manager approval. When we create this, we see that Kogito says, okay, we have an instance of our order workflow, and this is the ID generated. But its state is active, which means we cannot complete it until our manager has approved this decision. At the same time here, we will see that our human decision service that we have has generated an event which says, okay, I am in a ready state, which means I need a human decision to be made. And we see here in the manager approval section, okay, we have an option. This is my order ID. This is the cost. And we have simply can either approve it or deny it. When we click on deny, let's see what happens. A lot of things happen. The engine itself has told us, okay, I was in an active state waiting for a human decision. Our manager has completed it. And now my workflow orchestration instance is in a completed state. The same thing really for the human decision service. What we were doing is waiting in a ready state for a particular manager decisions. And once we have denied it, we've seen that our human decision service has generated a cloud event which says, okay, I am done. And in this case, our workflow has generated an event, which is our final decision, and we can see it here at the end. So that was really the demo that I wanted to show if the internet worked out correctly.
So we will make sure we record this demo in a smaller video to leave it on our YouTube channel for people who are interested on it. But I have a question here from Shire Temp. He or she wants to know if there is any tool or something which will help to create JSON rather than writing the entire thing for complex workflows.
Definitely. What we have is we have created a plugin for VS Code Editor. Let's see if I can actually show it. Oh, if I could type correctly.
That's okay. You're just nervous. It's okay.
Yeah, I'm just mad about the internet. But here is, for example, you can get it through VS Code itself, or you can go to the marketplace. This gives you JSON support or the schema support for writing the serverless workflows in your IDE. It works on both, should work on both JSON and YAML, and it currently has been updated. I've updated it just yesterday to the latest snapshot of the serverless workflow specification schema. So you should have everything that is used within the demo. If you get it, you can, and it gives you, as you can see, and let me show you just an example. For example, on different states, let's see, we have a switch state here. If you wanted to go in here, it does auto completion for you. So you have all the different states available and stuff like that right away. And all the parameters, you have auto completion and everything going on.
That is awesome. And I have one more question here from Kevin Malk. How does the waiting for a human approval event work with serverless?
Well, Kogito runtime has a human, it's basically within your workflow orchestration, you create a wait state. And these wait states, basically, you can, at that point, wait for a decision to happen. And that's kind of like, it's basically our workflow definitions. During the execution, your workflow instance can run into a wait state that says, okay, I have to wait until some event happens, or I have to wait until a human decision is made. So basically, we can, with Kogito, target both stateless and stateful orchestrations. That's one of the benefits of what we're kind of trying to do or trying to have here.
Very nice. So we are on the top of the hour, unfortunately. Tiho, I just stopped sharing your screen. So I would like to thank you, Tiho, for being here and for coming back after this internet problem. That's awesome that the demo you have, we'll make sure that we share that later with the people who are interested on it. Thank you, Tiho. And a special thanks to you who's here watching us. And I hope we can meet on the next Key Live. Have a nice day. Bye-bye. Stay safe. Bye, Tiho.
Bye, guys.